Thank you.
Thank you, Dr. Roberts. We have Michael Shields from Google, who's been working with VJ on a favorite topic of theirs. Yeah, we have it right here.
I've changed the slides around some.
You have, okay.
The DVI?
Can you, just regular. Here we go. See what's on there. All right, here we go. You just try to slide that in next to it and it'll fit. Will that fit?
That'll fit.
Great. Got anything yet? There we go. That's better. All right. All right. So, what I'm talking about today is automated network configuration. I think that this is a problem that every network I've worked at has had, and it's a problem that I think it is endemic. I think it is not possible to just be careful and have everything correct without tools, because I think this is something that humans are just fundamentally not good at. But the good news is that I found some general principles and some approaches that can help solve that. You know, I know that basically the classes of tools that are necessary, and more importantly, how you can get there from the network that you already have, because no one's going to go back and rebuild your network from scratch using the automated system that you now think that you should have had. I know that a lot of people wish to do that, but they're just not sure how to get there from here. And I've done that successfully in a few areas, so that's what this talk is about. So this is the traditional way to take your small network and make it a little bigger. I mean, you buy equipment, you put it in place, and you log on the device, and you think about what you need, and you look at your documentation, and you look at some previous configs that have done about the same thing, and you cut and paste, and you turn around and have someone else check your work to make sure you haven't made any mistakes, the same usual sorts of typos that we see over and over. And then you go and commit everything, and you turn off the monitoring, and you move on, and you think everything's great. And almost always you're right, because we're all smart people and we're careful people, and generally everything works out. But it doesn't happen every time. It only happens most of the time. And the times that it doesn't happen are really frustrating. And it's something that seems to come up more and more often when you have something which is a network-wide impact. A good example of that is IBGP configurations that need a full mesh. If something is missing from that, then you get random mystery black holing. It's really unpleasant to debug, and when you find it, you wish the problem had been something else, because it just completely wasted your time. So here's an example of that. I'll just do this as a case study. This is basically the simplest possible configuration. You have two routers set up in a redundant pair, and you have a segment behind them, and you have some servers, or it's a colo customer, whatever it is. It's as simple as it gets. This is networking 101. So you have a template. You've done this plenty of times, so you just you just want to plug it in. You know the interface, and you have the address, and you make one router 120 for it, and one 100, et cetera, et cetera. It's no problem. You plug it in. You copy it. You kind of paste it to the other router. You change some things around. You paste it on that router. Everything looks fine. Same thing it always is. And what you don't notice this time is that actually something is wrong. You've given both routers the same IP address because you forgot to change it. I'm pretty sure everyone here has done this. I know I've done it. I found it in other people's configs. It's the same, just simple sort of mistake that is inevitable. It happens because people cut and paste. People cut and paste from other routers instead of the documentation, because it's more convenient to look at a config somewhere else than it is to go back and find the official procedure for what it is. If you have some sort of an error, or if it's a one-off config that was deliberately different, then you'll see that propagate elsewhere in the network. And sometimes you can see that happen in strange places. Sometimes you'll even see things like your SMP committee will actually get set to stars or to X's, to the literal. And of course you don't notice that until monitoring fails. But humans expect to see patterns. People expect everything to be okay, because it almost always is. And they'll see things that aren't there. You can look at something, and if 100 of them are, if you're looking at 100 things and 99 of them are the same, the odds are very good that you will not notice the one that isn't. And that's the one that is going to catch you, and that's the one that's going to result in you getting paged. You're not going to find all the errors just by looking unless you spend an interminable amount of time doing that. So these are the most common things that go wrong. I've seen it over and over. Some of these are pretty insidious. The ACLs especially, because that's something that you're likely not to notice until you see the packets and you have to track them back to somewhere where they should not have been able to come from. IP address confusion is another good one because that's something where you can assign the same block here and there or it's overlapping, you just forgot to record it. Who knows? I mean, there's any number of errors that can crop up there in that general field. And the typical response that people have is that you do it bell system style, where you have someone punch down the wire, and you have someone come go back and write in the book, and someone make sure that the wire that was punched down is what's written in the book, and then you have people spend all day looking at the book against what's in the patch panel. It's really tedious, even if you have the army of people that can do it, as AT&T did back in the day. You can't ever keep all your documentation up to date. You can't ever keep the network consistent. There's always going to be some level of errors, and you'll go blind trying. I mean, you'll spend all your time thinking about the individual interface level instead of doing the network architecture that you need to be thinking about. So if you want your network to be big, you have to automate it. If your network is small, then it doesn't matter. Everything is a one-off. Everything is ad hoc. You can just look at it. But when you have even a few hundred routers, then it just becomes unmanageable. The more actions you take, the more mistakes you'll make. And any large network is built out of thousands and thousands of individual actions because you had to configure everything individually. If it's not automated, it won't scale. And the correct networks will scale better than they will. They'll scale with less effort. They'll scale with higher uptime. I mean, they'll scale with more interested engineers because their job will be better. I mean, they'll not spend so much time tracing down problems that turned out to be fundamentally silly and just random errors, just random typos. I mean, it's frustrating when the root cause of your problem turns out to be only a typo. It's much better when you can blame it on vendors. So everyone wants an orderly network, but the problem is that you already have a network. So you need to figure out how to get there from here. There's a couple ways you can do it. I mean, one way that people commonly take is that they'll take an individual router and they'll start trying to write a generator that will generate that config, and they'll figure, oh, changes from here on will have to go through the generator. It doesn't work because you basically have to, because the nature of network is that they're tied into everything else. So there's no way to slice it based on one router. You have to slice it across. Like you solve one class of problems. So you can solve the problem of duplicate IP addresses or of incomplete IBGP mesh or whatever other class of problems that you want to solve. But you have to pick one and slice it across. So the way that works is that you have a template, like the example I had before, except that it's fully automated. So you go and you put the config that you want into a database, and then the config falls out of that. I mean, it tells you, apply this to the router. And the important step is that then you can go back anytime you want and check that that's actually what did get applied on the router. And you can go back on a continuous basis and find all the cases where that did or didn't happen. And it forces you to document the cases where you did something on an ad hoc basis. That way, anytime something is different, you know whether it was something that was a deliberate decision, which happens, or whether it was something that was just a mistake, which also happens. But this way you know, and there's no wondering. And particularly, there's no wondering at 2 in the morning. So the policy here is don't touch the router until it's in the database. For this example, we could have had it by just defining by defining in the database right now, I'm setting up a new Ethernet segment, and it's going to have this pair of routers. And from there, you then have a database of all the addresses that you've set up that way. So that way you can go through and you can scrape your router configs, you can parse them, and you can make sure that everything that's in there is actually in the database. So you start with a pile of routers, and you start putting information into your database. This is step 1. Because you're starting with an empty database. So you go through and you write something which will scrape everything, put it into there. And as you do that, it immediately gets more and more useful. Because you can also go back now and you can query the database. You don't have to go through all your routers looking for something. You don't have to actually log in and do trace routes or look at your routing table. You just go right here and it can tie into your other tools. Your ticketing system can have hot links to it, or whatever systems you have in place. Just go and tie them right in. It never has to actually talk to the live network to do so. Once you've done that, you can start actually applying the configs from the database. Now, it's up to you whether you want to do that automatically or not, or whether you want to have humans review it first, or whether you want to, do manual pushes. But without review, it's your own risk assessment, no matter what part of the config that you're trying to, that you're trying to push out at that point. But once you know that such a config is always supposed to be, by policy, correctly generated from the database, then you know that anytime that what the database says is different from the router config is an error in either the router or the database, and you can set off an alarm and someone can go look at it. So here's an example of the audit that we could have had that would have caught this problem right away before anyone noticed. It would have caught it right there at turnup. So there's a couple of reasons that you'll start seeing errors, once you start putting things into the database. Number one is that your router parser code didn't correctly figure out what your cases were. That's an easy problem to fix. You just fix that, and you rerun the importer. Number two is actual configuration errors. These are surprisingly common. Even for things like assigning the same IP address to multiple interfaces. I mean, typically if you go through and sweep that, you'll find, you can find dozens of cases where someone has put the same IP address in two interfaces. No one has noticed, maybe for months or years. I mean, it's amazing that can go on, but it actually does. I mean, our networks are large enough and have enough corners that really can't happen. And this is every network I've worked at here. This is not a Google-specific talk. And the third case here is deliberately unusual configuration. Because you'll find a lot of cases where someone will have something which is just almost the same as the standard config, and they'll just go and they'll just configure it that way, and everything works, and that's great. But the problem is that you never went back and wrote down, this is the standard way that I configure something which is slightly different. Or you didn't write down, for customer X, they're almost the same, except it's slightly different this way. Now, this way you can make it either a standard config for everyone, you can make it a one-off for just for them, but whichever way you choose, it's an explicit decision, and it's something that you have recorded. So it's important to be able to go back and recheck it at will. So it's important that you be able to go at any time and take what you have generated and what you have on the actual router and put them side by side and figure out how they differ, if at all. And you need to be able to say that, I'm going to intentionally say, this is something that I'm going to ignore and put in an ignore for it. Or it's something that, you're going to go back and fix either the router or the database based on which one of them is incorrect. So this is an example of an actual audit. It doesn't take a lot to build a system like this. What you need is you need a database, and you'll need a templating system. It can be any templating system that you're comfortable with and that everyone you work with is comfortable with. As long as it has loops and conditionals, then that's really all you need. So the way that our system works, it goes through, pulls things out of the database, and generates a text config. And the important operator here is the ellipsis. The ellipsis is not something I've just put on the slide. The ellipsis is actually part of the audit. The ellipsis is something that is the ellipsis is an operator that matches any text which is at an equal or greater indentation level. So what this says here is that, from the protocols, we can have any number of protocols, but there's, and the OSPF section can be before or after that. Or there can be anything before or after the OSPF section. But within the interface, for example, all you can do on it is apply a metric. You can't apply anything else. So your audits don't have to look like this necessarily, but they'll probably look in this general form. Basically, the idea is that you generate something, and you can compare it against it, and you'll need some way of selecting what part of the config that you're comparing it against. It's not necessarily productive to try to compare complete configurations until you're really far along with this. I've tried it once before. It results in people getting used to seeing diffs. You don't want people to get used to seeing diffs. You want people to get used to seeing that everything is okay, everything is exactly in line with how we expect it to be. So that's why you need to look at just part of the configuration at a time. So the way this really pays off is when you need to make a sweeping network-wide change. So the way, generally that becomes a giant, it's a giant project. It takes, the bulk of a year because people have to go and write configs. They're kind of, on pins and needles if they want to do something like, say, change, from OSPF to is, and they have to go and write the configs for each individual router, or they're changing it from one vendor to another, because no one is really sure if they got it correct. I mean, there's a lot that can go wrong there. But if the change you're making is within the scope of what you defined, then all you do is you add what's new to your database, and then you tell the generator how to generate the new sections of the configuration. So here's an example. You've just added all the is sections. And you go and you apply that to every router. You swap the metrics around. You've probably seen a talk on how to do this before. And there you go. You're done. And that's something that was done without having to sit down and look at every individual router. This is the thing, is that you're now looking at the level of the network. You can think and operate at the level of the network, and you can make network-wide changes. You're not always sitting down looking at each individual detail. You're not sitting down with the book and the punch tool trying to figure out that everything is correct. So in this case, your router configuration is no longer just a log. It's no longer just the accumulated set of changes that people have made to it. It's actually a function that you can apply to your database. You take the database input, you apply a function to it, and then what you have is what the configuration ought to be. And if you change what your architecture is, you just define a new function, f prime, you apply that to the same data, and you get something which is what the new configuration ought to be, and you can go and apply that. So the one wrench in this is, what do you do about one-offs? There's always going to be some things that are just really, really weird. There are two ways to approach that. One way is to just say, I'm going to ignore this section of the config, and that's a perfectly valid approach. I mean, it's like silencing the alert, it silences the alarms. It says, this is not the same as a standard config, but I'm going to forget about it because this is a non-standard config. The other thing you can do that's better is to treat yourself, even internally, as if you were a colo provider, and define an architecture for isolating things in such a way that they can't harm the rest of your network, no matter what weird things they do. This is really good for acquisitions. If you have a company that you bought and you haven't assimilated their network yet, then you can go and you know that you have something already that you can pull off the shelf and just put them behind this jail router, and then they're not going to, you don't have to worry about what sort of weird one-off you're going to build for them. You've treated them like a colo customer. So that's a summary, is that anything that you do routinely is something that you need to start centering around an audit if you're going to have a higher level of accuracy than you can get by hand. It's up to you whether you want the high level of accuracy. If you're happy with the amount of work that you do currently and with the level of accuracy that you currently get, then there's no need to do this, but I think there's a lot of benefits to doing so, and I think it's the only way to get beyond the level that you can have by hand. The way to get there from not having it is to start with one class of problems at a time. It seems like IP allocation would be there, but it often is. Often, the problem of then I need an IP allocation database is trickier at some places. So IBGP mesh is something which is, it doesn't tie into anything. So as long as you have a database of routers, you can pretty much generate that. Almost everyone can start with the IBGP mesh. You want to continuously compare your generated configs against the actual configs, and you want to get the diffs down to 0. You want to get that down to a point where everyone is used to seeing it all line up. And if you can afford the hardware to do so, the best way to isolate the non-standard configurations is to treat them as colo customers and then make a jail there. So this is not something that small networks need, because in a small network, you don't do things routinely. You don't do things hundreds of thousands or tens of thousands of times. You do things as they come up. And it's surprising how far you can get with that. But the big ones do need that. I mean, this is something that basically humans are not good at and that computers are good at. And I think we would all do more of it if we had more experience with it, and if we had more experience with being able to get to that point, from the point where the configuration is just the accumulated, just the accumulated changes that everyone has made. There's no way you can do it with a fight day, because you'll have to generate the complete config and then cut it over, and you'll have to worry about it, and your project will never actually get to that point. It's like any software project where you want to find the smallest thing that can make progress and start implementing that and get people used to it and get some feedback on it, and then start rolling that out. That's it. I know we're a little short on time. I think I've tried to catch up some. Any questions?
Hi, Joel Krausker from Slide. I've tried to implement lots of these things before with parsing configs and then trying to dump them into the database. That's not trivial, in my opinion. So, I want to ask if anyone here has some good bases or tools for that. That'd be really awesome and help for the entire community. If we could get something like that open source and made accessible to everybody.
Yeah, the problem with that is that everyone's network is different. I think that there are some things that, there are a few things in common, but the database itself is something you almost have to build yourself, because it's something that's going to have to be custom to your database, and that is the hard part. It is a really hard part to build. But just start with something you understand, like having a list of all your routers and their loopback addresses. If you start there, then you'd be surprised, how beneficial that turns out to be. Another question over here? Mm-hmm.
Yeah, Owen Roth from Impulse. So my question, and I had some experience with like auto IT and these kind of scripted, configurates, I guess you called it, was primarily, and I don't think you addressed it, is that you have a way of your configuration, your analyzation tool, ignoring a certain subsection before OSPF and after OSPF. And you have a classification scenario when you have non-standard implementations. So my question is, how have you automated people go in there and they throw in whatever crap they want to. Do you have an automation tool that allows you to determine what is non-standard without relying on all of your administrators flagging it as non-standard?
It would be, so anything that's anything that doesn't agree with what you got out of the database is it's either a bug in your generator, which happens, but it's easy to fix. Or it is actually non-standard, or it is something that should have been standard, but you haven't made it a standard. You haven't correctly documented that, or you haven't correctly told the generator about that. there's no way of automatically distinguishing between the last two cases. There's no way of it knowing whether something was standard but just didn't get into the documentation. People just kind of know about it. That happens a lot. They just know that when something comes up, they should do it this way. Or whether something actually is wrong, whether people kept doing it that way, but they should never have. That's a decision that has to be made by looking at what sorts of errors you have and seeing if you can find some patterns in them. And then you have to decide whether you want to fix all of them or whether you want to make all of them standard.
Another question over here.
Yeah, particularly as you're looking at automation, first off, what has your experience been with NetConf so far, or actually an actual implementation? And then secondly, with regards to, particularly with a lot of things where establishing a database can often be difficult for getting a lot of these things started, how have you prioritized monitoring consistency configurations based on the observed running state of protocols as opposed to necessarily scripting their actual runtime configuration?
Those are good questions. So I think NetConf I think the major goal of NetConf, as I understand it, is to get the Juniper XML the benefits to everyone. That's it. Yeah. There's been pretty limited vendor support for that, which I've been disappointed in, since that's something that Juniper did a long time ago that I think was a really great idea and that I think should have been more widely adopted. I would like to see more vendor adoption of NetConf, because that certainly makes writing not just these tools, but all sorts of tools a lot easier. With that said, even with what you get out of Rancid, you can still go really, really far with it. Without doing any sort of real-time protocol state scraping, without doing anything like that, with just comparing the configs, you can solve a lot of classes of problems, and that's something that it's kind of the low-hanging fruit there.
Okay, so overall, your emphasis would be on building consistent configurations as opposed to necessarily monitoring state.
I'm sorry, I can't hear you.
Your prioritization then would be automating configurations as opposed to necessarily monitoring state.
Yes, I would say so. So I think that we pretty much already have good systems to detect when interfaces are down and shouldn't be. I think that's a solved problem at most networks.
Hi, Chris Spears from Ornet. I want to concur that yes, seeing too many diffs does lead to difference among those people in our staff and people that have to see those. They start to really sort of disregard them. We've been doing this for several years with automation and checking up on the status of the network. Now, one thing that we've started to do, because there are too many hands in the cookie jar and that people don't follow our procedures that we've set in place, even after auto-generating things change. We started implementing commit scripts and op scripts to really just check that the person that actually saves the config off is doing it the right way. I was wondering if you guys have started doing that.
So in general, there's a hesitation to actually prevent people from doing things rather than just warning them about it. Often, if you tell people that something seems unsafe, then they should still have the ability to override that, because often they have a good reason, or it actually isn't unsafe. It's just a bug in your check. So I think that rather than preventing engineers from doing their job, it's better to just give them tools that will help them do their. That's part of this. This is not really even a the whole point here is that this is not that engineers are lazy or careless, because this is something that is inevitable. It's something that humans are just not good at. And if you give people tools that are better than what they have now, if you give people tools that are easier to use than cut and pasting or pulling stuff out of the documentation and filling in blanks, then I think that you won't have any resistance in getting people to use it. All right. Okay. Anyone, one more?
Hi, Richard Steenberg and Inlayer. So I just wanted to comment on the use of commit scripts because that's what we do. So basically the approach that we took was to say that there's certain things that you're not going to be able to store in the database either because it's too complex or it's too hard to design your database to cover every possible one-off that you might need to cover. So there's certain things that you can push out to database generated and script push configs. Like for example, prefix list generation is a perfect example of that. But what we found was really heavily relying on commit scripts. While still giving people the ability to override stuff, but really simplifying a lot of the configuration itself and making it so that automated systems do a lot of the work on the back end that the operator doesn't see or doesn't have to be concerned with, and that adds additional safety checks is a huge benefit. And when you get your config, when you take a 10,000 line config and you get it down to 400 lines because you've got beautiful commit scripts, it makes it much easier to manage.
Yeah, that's certainly another approach, that essentially you put the generation in the router itself. Yeah. Thanks.
Thank you, Michael.